Okay, I think we are live. Good evening, everyone, from the Death Valley region of California. Welcome to a pretty nice late spring evening. We got a little bit of breezes going on here every now and again, but it's supposed to be calming right down. It should be a gorgeous evening for us to look at some cool astronomy objects. So, before I do that, I'm going to, let's see, I'm going to need, what I should do first, this is what I always should do, is get the image of what I'm actually using to do these broadcasts. So let me turn that on and this off, and there we are. I think we're good there. Okay, and this is my telescope that I'm using to do these broadcasts. It's a simple 6-inch f4 imaging Newtonian, and the camera goes in up top here, and this is the mount that drives it all, and I'm sitting behind this table right here bringing this all to you. So just a simple little telescope, but it works really, really well, especially with my dark skies. And so that's the kind of telescope I'm using. So let's get to, okay, now one of the things right now I'm on Regulus. That's what I used. No, not that one. Where am I? This one, that's what I'm looking for. So right now I used Regulus to get myself focused, but what I didn't do is get my screens resized so that you can see all of my screen. And while I'm doing that, I should also get our list up here so we know what we're looking at. Okay, monthly observing challenge. Why am I not seeing it pinned here? I'm observation, oh, right there at the top. For some reason I'm not seeing it. Okay, so yeah, a good way to start, especially with the skies we got right now, is to start with a nice bright cluster. So that's what we're going to do. So let's go to M67. The GoldenEye cluster, or the Pac-Man cluster. Alright, let's send the telescope over there. So this is going to be one type of cluster called an open cluster. There are at least two major kinds, an open and a globular cluster, which is a much more condensed type of cluster, which we've looked at last time or two, I believe. We looked at some open. We looked at both kinds of clusters, if I recall right. Come on, I can't grab this corner. No, it won't let me grab this corner. I don't know why, but it won't let me grab that corner. Okay, so I couldn't do that. Alright, I gotta get all this set up. I gotta get this set up. Okay, and then this, and I'm not going to want to use 30 seconds for a cluster because you just don't need that much time. So we'll try 30 seconds. See how that works. Okay, in the meantime, how's our window size here? It's not too bad, actually. Not too bad at all. I think I just come in a little bit and I think just up a little bit. That might work. Alright, there's our first sub. Okay. Wow. I don't know where all that red is coming. Oh, yes, I do. Yeah, so we're not going to be able to, we're going to have to stay on this. We're not going to have a lot of time on this because it's really low. It's setting into a roof line, which is what this discoloration is. So we'll be able to look at this only for the first couple of minutes. We'll spend a couple of minutes on it, but yeah, it's going into a roof line, so this is going to keep growing in on us. Okay, and hello Cosmic Ray. What scope and what camera? Well, I just talked about that a minute ago, but I'll bring it up again here. It's a 6-inch f4 imaging Newtonian that is running on an AM5 strain wave harmonic mount, and the camera inside is an ASI 183 color. All that information is also in the description on this video that we're doing, and you can look in there for more information at the software that I'm using, etc. But yeah, it's a imaging Newtonian that I'm using, a simple reflector telescope. Okay. Yeah, this is got a lot of crapola on this side, unfortunately, because of the because we're setting into a roof. So, all right, I gotta get this resized because this is the wrong size as well. Okay. Oh, not that. That's not the one I'm trying to get to. That is. Okay. Alright, now back to our image here. Okay, now what did Errol had to say about this? I think I'll bring it up over here. No, Ray, I'm not. I'm actually outside with it. You can probably actually hear the wind noise in my microphone now and again, because I am definitely sitting scope side. I prefer to be out under the stars when I'm doing my astronomy, even though the bugs get annoying and temperatures in the winter can be a little cold. But I just went out and bought myself some heated apparel for the winter time, so cold is much less of an issue now than it used to be. But yeah, I like doing my astronomy out under the stars. Okay, so the Golden Eye cluster. This Errol says this open cluster is about 2,700 light years away, and it is visible in the western sky early in May. It's an easy target for almost any setup. M67 has about 500 members and is one of the oldest open clusters in our galaxy, with a variety of stellar types, including many similar to our own sun and a lot of red giants. Our view of the cluster from Earth is unobscured with minimal interstellar dust. So it's one of the oldest clusters in the Milky Way, in our galaxy. So It's a pretty nice little cluster. Definitely got some nice little stars there. Let's see if we can get the colors. I am located in just 25 miles southeast of Death Valley National Park in eastern California, about 80 miles due west of Las Vegas, just over the California line. So my skies are probably about high Bortle 2-ish skies here in my yard. I'm not sure what STLS broadcast is, so I guess that would be a no. Alright, again this is M67, an open cluster deep in the western sky, and just about to set into a roof line, which is why I'm getting some of this discoloring over here on the right. Let's see, but we're going to get off this object here pretty soon. M104, Great Challenge, Deep Southern. Yeah, we'll be able to do those southern targets. Let's see, 104 is going to be up here, I think. No, that's Spindle. Come on. No. Where's M104? I know you're in here somewhere. Yeah, there it is, right there. It's actually in a pretty good spot. Right above Corvus, which is right there. Yeah, that's in a good spot. So we will jump on that here next. Oh, Sky Tour Livestream. No, I have never seen his broadcast. Okay, well this is bugging me, so we're going to get off this. But anyway, star clusters don't take long to resolve, so this is definitely a pretty cool cluster. We're just setting into a roof line, so it's just time to move on. But I'm glad I did this first, because I would not have been able to do it any later. Okay, so now we're going to go to M104, the Sombrero. Okay, yeah, there it is. Right down there. I'll bring that right up in the center with my plate solve. And then we will start our stack. The Sombrero is a pretty cool object. Okay, and where am I? I'm here. Okay. Oh yes, and let me also get my background music started here. So at least you guys got something to listen to when I'm not yammering at you. Let's make sure we are on our target here. Yeah. Bring these colors back into line a little better. Alright. And there is our Sombrero galaxy. Oh yeah, sea star. Those are a lot of fun. I have a couple friends who have sea stars, and those are a lot of fun to bring around. Definitely very portable, and for what they are, they give surprisingly good little images. Okay, Wikipedia. The Sombrero galaxy, or Messier 104, is a peculiar galaxy of unclear classification. It's about 31 million light years away, and it's a member of the Virgo group. It has an isophotal diameter of approximately 100,000 light years, so it's slightly bigger than our own Milky Way. It has a bright nucleus and an unusually large central bulge and a prominent dust lane in the outer disk, which is viewed almost edge-on. The dark dust lane and the bulge give the appearance of a sombrero hat, thus the name. Astronomers initially thought the halo was small and light, indicative of a spiral galaxy. But the Spitzer Space Telescope found that the dust ring was larger and more massive than previously thought, indicative of a giant elliptical galaxy. The galaxy is easily visible with amateur telescopes and considered by some authors to be the galaxy with the highest absolute magnitude, in a reasonable distance from the Milky Way, so the closest, brightest one to us, basically. Its large bulge, central supermassive black hole, and dust lane all attract the attention of professional astronomers. So they like looking at it a lot. And it is a cool looking galaxy, there's no doubt about that. Hey Gary, thanks for stopping by. Good to see you. Things are going pretty well out here. We've had a nice spring. I had a couple of nice nights here last night, and tonight are both fairly decent. A little bit light breeze here or there, which thankfully doesn't stick around very long. It's supposed to be dying off, but you can probably hear it in my microphone as always. But yeah, been good. Alright, let's knock that down a little bit. Knock that back a little bit. Nice and cool, very overcast. Yeah. The marine layer is in on you, huh? Yeah, we've been getting some pretty steady southerlies, so I guess it makes sense that you're on shore down there. Get a nice onshore breeze. Oh, cool. Observatory. So you're gonna go for the push button observatory, huh? You can see it's got a really nice, sharply defined dust lane around the edge. It's a pretty cool looking galaxy. Well, good evening, Paulette. Thanks for being here. Budget astrophotographer, I can relate. Or at least that's how I started out. But, you know, astronomy, like almost any other hobby, is a black pit you can sink as much money into as you have and then some. So, good luck keeping it budget. Yeah, I like, you know, I wish the 183 wasn't quite so noisy and grainy as it is. I wish they'd come out with a newer version of the 183 sensor. The newer crop of sensors like the 533 and the 2600 are really nice in terms of their lack of noise. They just seem to be a lot smoother. And, you know, 183 is an older sensor, so it's still kind of grainy and noisy, but there's just no beating its small pixels. For a small focal length, it's just great. Paulette, this is the Messier 104, or the Sombrero galaxy, which is right now pretty much, it's in the southern sky, but just west of the meridian. So it's depending on where, I'm not sure where you at, but if you're in the southern part of the country, you should be able to see it pretty well in your southern sky. With a telescope, of course, you're not going to be able to see it naked eye. Oh, you were imaging the Sombrero the other night? Nice. It is a pretty cool galaxy. And what do you use, Paulette, for a scope and camera? I bring a picture of mine back and forward. This This is what I'm using, 6-inch imaging Newtonian on a ZWO AM5 strain wave mount, and then ASI 183 camera stuck in the top, and that's what's running everything. And I'm sitting here behind this laptop running all of it right now. So that's what I'm using. What do you use when you take your photos? Ray asks, why gain 111? Well, because the gurus who know a lot more about these cameras and digital sensors than I do did some testing on it, and they discovered that for the 183 sensor, 111 gain setting is about unity gain, which is a good balanced place for the sensor to be used, basically. And so it's a happy compromise between noise being produced, yet brightness also being produced, and proper color saturation and everything. So it's sort of the optimal place to use a 183 color. .70 by 400 travel scope and a 120 color. Okay, with an X-star. Are those cinder blocks glued together? You betcha they are. That's my spare no expense pier. And yes, the blocks, I used construction adhesive to glue all of the blocks together, but the bottom part, the bottom blocks are not glued to the pad, so that if I need to, I can put a two-wheel dolly under here and move the pier around, which thankfully I basically never have to do, but I can move it if I want to. But yes, this is how I built the pier, and a couple of pieces of scrap metal under here to shim it so it doesn't rock. It stays completely strong and stable. And yeah, all the storage space that's in here came through at no extra expense. Just came along for the ride. So yeah, that is what I am doing these images on, and it works really well. So out here in the desert, we hit 120 degrees in the summer, and can get down into the teens overnight in the wintertime. So we definitely have temperature extremes here, and so I can't really leave any electronics out. I can't leave anything outside. Obviously, it's too hot in the summertime. The mount and the scope and everything comes in with me, but the cinder blocks are impervious to it all, so they can just stay set up. And all I have to do is carry the little 11-pound AM5 out, and the scope, a couple of boxes, plastic tubs, one under here, one there. You can see that I have the stuff in, and just carry that stuff in and out from the house. But the cinder block pier gets to stay. Cinder shelves, yeah. So Paulette, that looks like a good basic little setup. So it's a 70 by 400 millimeter, so travel scope. So that sounds like a refractor, and you've got it on a Nexstar mount. Okay, and I assume the Nexstar mount is computerized, so you've got go-to on that. You star align it, and then you can send it to the various objects, I'm assuming. I actually had a Celestron. I actually have had a number of Celestron telescopes and mounts in my day. I had an SLT mount that I put a couple of different things on it, basically an SLT 130, and ran a couple of scopes on that old SLT mount. And I never had an SE, but I upgraded to an Evolution 8, and And from there I upgraded to an AVX, my first equatorial mount. And then from there upgraded to this, the ZWO AM5. Carrying the AVX in and out, 50-pound mount, got a little bit more than I wanted to do, so I really love the 11-pound AM5. It's just great to bring in and out. Just screw it right down here. I've got a big eye bolt right under here. It just screws up into the base, attaches it to the cinder block pier, and so I only have to carry this out, and everything's fairly light and fairly compact, which on my aging back is a good thing. Yeah, the Sea Star puts up some really nice little images, no doubt. For what it is and what you pay for it, it does a pretty decent little job, and it's just fun to use. Something to be said for ease of use. You know, this setup of mine takes some time to set up every night. I've got it down to about half an hour where I can go from starting to carry things out to set up and polar aligned and flats taken and stuff, and I can be ready to go in about half an hour. But you know, something like the Sea Star where you can just plunk it down and it does all of its calibration itself and you don't have to do anything. That's kind of nice. We'll let this go a couple extra minutes, just because it's such a nice object. Just a great dust lane and a nice bright core in there, which apparently has a supermassive black hole. So, I'm sure that's exciting. But it is just a really cool looking galaxy. Stretch a little bit here. See the dust lane a little better. Yeah, Gary, it's 50 millimeters it's a nice wide field setup. If you get some good quality glass in it, you can get some nice wide field images out of a smaller scope. I mean, my guide scope is 60 millimeters that I have on this, and see, is there a picture of it? No, you can't really see it. It's on the no, I just hadn't put a guide scope on here yet, I guess, because the guide scope is on. Oh, wait a minute, what am I thinking? No, the guide scope it's on the other side. You can't see it. This is backwards from the way it's lying right now, so but yeah, it's a 60 millimeter. Even a simple, achromat gets some pretty nice little pictures. And Ray asks, why the Newtonian? Because bang for the buck, they're just great scopes. They're great light collectors. They're fast optically, and I like both of those things. They're fairly light, they're inexpensive, they just work really well. They're simple and they work really well. And so I really like I've used Newtonians for a very long time, and I prefer them to refractors. Refractors are typically longer focal length and slower, which gives a cleaner image if you're a visual observer. But if you're an imager like I am, and I exclusively image, I've sold all I don't even have any eyepieces. I have a couple basic ones, but that's it. And so for an imager, the focal ratio, the speed of the optics is everything. So refractors, quite frankly, are just too slow for me. And so I like this using fast Newtonians. And this is native f4, and I'm using something called a Stellarium nexus in it, which is a Coma corrector and 0.75 focal reducer. So right now I've speeded it up to f3. So it's a nice fast scope, a good light collector, and even though you give up some sharpness, you know, some of these stars would be a bit sharper and tighter, the image would be a bit sharper and tighter, but it would be a lot dimmer because it's just the optics are a lot slower. So those are some of the reasons why I prefer Newtonians. Alright, we'll finish this sub and have 20 minutes on it. I'll call it good. It's a pretty little galaxy. What has he got next here? ARP 244, huh? Sombrero. Here's his picture of Sombrero. Okay, NGC 4038 is the next one. Alright, say goodnight to the Sombrero. And we'll head over to the NGC 4038. Okay, so we're going a little bit deeper into the... Oh, the Antennae galaxies. Okay. Yeah, these are some dim galaxies. So this could be interesting. We shall see. So we're going to go from one extreme to the other here. From a pretty bright galaxy to a couple of pretty dim interacting galaxies. So yeah, you got a 6-inch f8. You ground 50 years ago, just refigured it to 112. Gotta put it in tube. Yeah, it works better in the tube. 6-inch f8, that's a nice planet killer there. Got it down nice, figured it nice and smooth, so you should be able to do some nice planetary work with that. These are going to be a couple of pretty faint little Antennae galaxies. Are pretty faint things. ARP 244. They are. Ooh, nice blue star. Small and faint, but they are there. Alright, let's get our colors balanced again. Pop that over, pop that over. See how that works for a minute. Now we should be able to get some fairly wispy trails off this. It's going to take a few minutes of subs to get it, but should be able to get some Alright. Let's see what Errol has to say about these. Well, let's see what 4038 NGC 4038 4038 group antennae galaxies. Let's just go right to that page. The antenna galaxies, also known as NGC 4038 and 4039, are a pair of interacting galaxies in the constellation Corvus. They are currently going through a starburst phase in which the collision of clouds and gas and dust with entangled magnetic fields cause rapid star formation. They were discovered by William Herschel in 1785. The antenna galaxies are undergoing a galactic collision. Located in the NGC 4038 group with 5 other galaxies, these 2 galaxies are known as the Antennae galaxies because the 2 long tails of stars, gas, and dust ejected from the galaxies as a result of the collision resemble an insect's antennae. And we're not getting a lot of it yet. We push the stretch a lot, which will make it noisy. Probably see it a little better. Not really seeing it a whole lot yet. I think they're here and here. If I recall correctly, they're here and here. Little trails, faint little trails of stars. But we'll see what happens over the next several subs here. Yeah, they're gonna come in here and here. And laptop needs food. Let's get you plugged in here. There you go. Yeah. The nuclei of the 2 galaxies are joining to become one giant galaxy. Most galaxies probably undergo at least one significant collision in their lifetimes. This is likely the future of our Milky Way when it collides with the Andromeda galaxy. This collision and merger sequence for galaxy evolution was developed in part by successfully modeling the Antennae galaxies, antennae in particular. Recent study finds that they're about 45 million light years away. The Antennae galaxies also contain a relatively young collection of massive globular clusters that were possibly formed as a result of the collision between the 2. The young age of these clusters is in contrast to the average age of most known globular clusters, which were around 12 billion years old, with the formation of the globulars likely originating from shock waves generated by the collision of the galaxies compressing large, massive molecular clouds. About 1.2 billion years ago, the Antennae galaxies were 2 separate galaxies. 4038 was a barred spiral, and NGC 4039 was a regular spiral. 900 million years ago, the antennae began to approach one another. 600 million years ago, the antennae passed through each other, looking like the mice galaxies. 300 million years ago, the antennae stars began to be released from both galaxies. Today, the 2 streamers of ejected stars extend far beyond the original galaxies. So we're just starting to be able to pick it up a little bit here. Just starting to be able to pick it up right in there and right in there. Gary says, how are you finding SharpCap these days? Seems to have many new features. Yes, it does have many new features that are pretty cool, but what I've also noticed, as new features have come in, it's getting slower and slower. Screen refreshes, new subs hitting the screen, landing, getting added. Things just seem to be getting slower and slower with it. So, and maybe it's my machine is aging too, but it seems to definitely be getting a little bit slower as time goes on, as he continues to add really cool features to it. Lots of good stuff in it now. Been using Nina mostly due to the observatory control functions. Yeah, Nina is pretty cool too. I looked at Nina. And if I was more on the astrophotography side, I'd be using Nina instead of the more EAA focused SharpCap. Yeah, because I'm so EAA focused, SharpCap just makes more sense for me. But Nina is a great alternative, and it's hard to beat the price of open source. Yes, Ray, I am guiding with PhD, which is running right here. And, yep. Guiding, because of the breeziness, the guiding is not great tonight, but it's doing okay to get our images. So, and yes, I do use a Batinov mask to focus since I'm out at the scope. Using the mask is very easy, quick and easy. So that's what I do. Yeah, Nina doesn't work as well for EAA. Some people still do it, but yeah, it's not really optimized for it. If you're doing EAA, SharpCap is the place for you to be. If you're doing AP, nothing beats Nina. It's a good, well, I don't know, nothing, but it's definitely more geared toward AP of the two pieces of software. So, yeah, I never really got very far with looking at it because it just not aligned with what I am interested in. So yeah, we're starting to now see these antennae a bit better. You can really start to see the streamer of stars and gas and dust here that are being ejected by these two colliding galaxies. They've come together and they're merging, and that intense gravitational process is having a number of effects. The starburst effect being one. It's generating all kinds of new stars because of the energy being imparted by these two massive magnetic fields, gravitational and magnetic fields coming together and interacting. And also it's ejecting a bunch of stuff, so it'll probably lose a bunch of stars and gas and dust here too in the process, which may or may not recoalesce over time when this eventually comes together as one large galaxy. But yeah, these antennae they're tough things to get without some pretty dark skies. I got some pretty dark skies, and even so it's still tough for me to get. Oh, hey Joy. Well, tell her tomorrow I said hi. I'm sure she's growing like a weed. Am I using frame rejection, and what threshold? No, actually, I'm not really using. I don't really have any frame rejection on neither FWHM nor brightness. I used FWHM for a long time, but I stopped using it in favor of brightness. But usually it's all pretty consistent. I get some pretty consistent numbers. These numbers are a little higher than normal. Again, the seeing isn't great tonight, but yeah, if I need to use rejection, that's typically I'll use one or the other of those. Anymore, I typically use brightness. Just if a cloud moves in, it'll reject, frames where the contrast has gone to crap. Yeah, well, thanks for stopping in. I appreciate that you did stop by. Yeah, that age is just, it goes by really fast. You don't think so when you're growing up in it, but that age goes by so fast. But I'm glad you stopped in, Gary. It's good to see you. And, I don't know, do you do any broadcasting anymore? Gosh, your broadcasts were foundational for me. They kind of got me started. Yeah, well, shoot me an email. Shoot me an email when you do a live stream. I think I'm subscribed to you, but for some reason my YouTube account is messed up. I'm subscribed to a number of people, but I never get any notifications of any kind about their broadcasts. I get other notifications from YouTube when somebody subscribes to me, when somebody leaves comments. I get emails from YouTube, but I never get any notifications of anybody I'm subscribed to, even though I'm subscribed and the bell is rung and all blah 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 blah. For some reason, I never get notifications, so. Yeah. Okay, well, I guess I haven't missed anything then if you haven't been broadcasting. You got to be a special certain kind of glutton for punishment to do these, though. Especially you. You always seem to have technical glitches that you are fighting through. I seem to have better luck with that. I'm not sure why. I don't have better gear than you do. I don't know. I seem to have better luck. So you were just surfing on YouTube and I popped up, huh? Oh, that's interesting. I think you're the first person who's ever breezed by accidentally. I guess I don't do it that often. I do at least a couple a month. Sometimes I do a few a month. It really just comes down to the weather. If my schedule and the weather and the moon, all kind of coincide, then I'll do a broadcast. But weather is just such a question mark that you never know. So. Yeah, but I try and at least do a couple a month on YouTube. I actually spend most of my time broadcasting on Night Skies Network, which is nightskiesnetwork.com, and it's just much easier to broadcast there. And unlike here, where I'm the only one that can be heard, and you guys have to text chat me back, on NSN, everybody can talk live. If you got a microphone, you can come into the broadcast and chat live, which is really nice, and it's a lot easier to broadcast from, and yeah, it's just a much better deal than broadcasting on YouTube. But the audience isn't necessarily as big because YouTube is ubiquitous. It is just everywhere. It's on apps on your phones. It's just available from everywhere. So well, you subscribe. If you could just hit the subscribe button right there below my below the window, you hit subscribe and click the bell. You will be notified whenever I set up a live stream. So that is the easiest way to be notified. Stellar flare from M-class stars. Wow. Stellar flare from an M-class star. Cool. Let me see if I can stretch this a little more at this point. At the risk of it being a bit noisy, we'll see the antennae a little better. Come on. We'll see the antennae just a little bit better. But you can definitely see that they're there now. That's why they're called the antennae galaxies, because it looks like insect antennae coming off the things, which is just stuff being ejected by their collision. Yeah, that'd be great if you stopped by, Gary. Yeah, I mean, nightskiesnetwork.com, and it's based on educational software called Big Blue Button. So when you go to nightskiesnetwork.com, right there on that home page, there's glowing blue buttons of anybody who happens to be broadcasting that night. And so if you see one that has Coma skies over the top of it, that is me. And yes, I do send out, well, actually no. When I'm broadcasting on NSN, I typically don't send out any notifications, because it's usually one-off. You know, I just like decide last minute that I'm going to broadcast and whatnot. So, but so yeah, it just, you know, if you have a night where you're just wanting to pick up a broadcast, just go to nightskiesnetwork.com and see if my name isn't over one of the buttons, and that'll be me there, and then you can just come in and chat. I get YT notifications a day after broadcast. Well, that's helpful. I don't get them at all. I don't know why. I've never been able to figure it out. I've looked at it. I've spent time looking at it. I've even dug into it with somebody who's a more experienced YouTuber than me, and nobody can figure out why I'm not getting notifications of the channels I am subscribed to. But, oh well. Ain't no thing. Alright, so we'll finish up this 20th minute here, and well, I guess we've already got 20 minutes on there, so let's see. What's our next? Intermediate, okay, so there's that. M99. Toward the right lower corner of the frame. Yeah, so I think we've got them pretty well traced out. Got it pretty well out, as good as we're going to get them anyway. Alright, M99, St. Catherine's Wheel. M99. I don't know what I just did there, but I don't think it was definitely the wrong thing. I just clicked on definitely the wrong thing. Okay. M99. Alright, let's find M99. And are we on the correct side of the meridian? Oh, we are. Excellent. Okay. Go. That's it for me. Time for bed. Hope to catch you again soon. Well, right back at you, Gary. Hope to see you again. Stop by NSN and we'll chat then. If not, hopefully I'll catch one of your broadcasts soon. But thanks for stopping in. I appreciate you being here. Good to catch up. Okay, M99. This breeze is still kicking up its heels now and again. Supposed to be dying off by now. Do you have image of TCO? I don't know what you're saying there. TCOBOR for before and after shot. I don't know what TCOBOR means. Uh-oh, did you miss it? Did you miss what? Welcome to the broadcast there, Evergreen. And no, the broadcast isn't done. I'm just going here. But we're just moving to M99. And getting a start on that. Boy, here comes the wind. Supposed to die off, so of course it's doing exactly the opposite. Blaze star soon to nova. So this is M99. Nope, we're still going here. Live stream's still going. I'll be going for probably about another hour or so. You missed the first hour, but not the second. Alright, let's see what Wikipedia has to say about Messier 99. Messier 99 is a grand design spiral galaxy in the northern constellation Coma, approximately 49 million light years away. And by grand design, they mean it's a type of spiral with prominent and well-defined spiral arms, as opposed to multi-arm and flocculent spirals, which have subtler structural features. The spiral arms of a grand design galaxy extend clearly around the galaxy through many radians and can be observed. Okay, yeah, so just nice clearly defined arms, which this definitely does have. Boy, it's going to drive my guiding nuts, this wind. Oh, well. It was discovered by Pierre Marchand in 1781. The discovery was then reported to Charles Messier, who included the object in his catalogue of comet-like objects as Messier 99. It was one of the first galaxies in which a spiral pattern was seen. This pattern was first identified by Lord Rosse in the spring of 1846. It has a pure spiral shape with loosely wound arms. It has a peculiar shape with one normal-looking arm and an extended arm that is less tightly wound. Wonder why that is. Maybe some sort of gravitational interaction. bridge of neutral hydrogen gas links NGC 4254, which is Messier 99, this galaxy, with Virgo H121, a hydrogen alpha region and possible dark galaxy. The gravity from the dark galaxy may have distorted M99 and drawn out the gas bridge, as the two galaxy-sized objects may have had a close encounter before parting. However, there is to be tidal debris from an interaction with the lenticular galaxy NGC 4262 some 280 million years ago. Oh, so it's NGC 4262 is colliding with it. I wonder if that's in this frame. Well, let's see if NGC 4262 shows up here. Yep, right there. So this right here is 4262. Just tighten that up a little bit. So this galaxy here, they're saying, has possibly interacted with M99 and caused this arm to perhaps gravitationally pull out a little bit. Yes, that's correct, Evergreen. I am 25 miles southeast of Death Valley National Park boundary. I'm not actually down in the valley itself. I live just outside the national park boundaries, about 80 miles due west of Las Vegas, in the eastern California desert. Excuse me. So we keep both these galaxies in the same picture, because it's supposedly interacting with this one here, which may have been what caused the goofy arm to stick out, or so they think. Yeah, well, it's yes. Well, I'm probably about Bortle 2 sky, high Bortle 2 or so skies, approximately, because Las Vegas is about 80 miles east of us as the crow flies, about the bottom 20-25 degrees of sky to my east. My eastern sky basically has a nice big light dome. It's, about 20 degrees, 25 degrees above the horizon, which is okay because I don't like imaging down that low anyway, in any direction, because the sky's too sloppy. So there is definitely some light to the east here, but most of the rest of the sky is pretty darn good. There's some towns around, one to the southwest of me here, and another one to the northeast of me. So there's little light balloons here, little light domes here or there on my horizon, but most of the sky is just pretty much dark, which is very nice. Definitely a benefit of living here in the desert. Yeah, we got aurora. We did get some aurora here. And it was visible, but not very bright to the naked eye. I took a 30-second exposure just handheld with my phone, and it was pretty bright in an exposure of that length. But to the naked eye, it was just kind of this reddish, faint glow. Where are you, Evergreen? telescope at 50 miles northwest of Phoenix. Yeah, so fairly close to Phoenix. Yeah, it took some exposure. But hey, it's some exposure to get it, but down this far south, where I am, I'm at... Oh, you're in South Dakota. Well, gosh, you must have some pretty nice dark skies. I'm surprised you couldn't see it better than that, being in South Dakota. You must have some pretty dark skies there. I guess unless you're in an urban area. Yeah, you said you're not rural enough, so you must be in some South Dakota town that's big enough to produce some light. Well, we're getting some nice color out of the galaxy and this beautiful yellow star in contrast to the blue and yellow galaxy. That's kind of nice. Turning out to be a nice nice image here. M99 and friends. There was a little bit where it was pretty visible. I'm next to our only major city. Well, I guess for astronomy that's not very good, but being next to a only major city is probably has its other advantages. Oh, this sunspot that's coming around again. Okay. Yeah, I don't do solar work, so I definitely don't have anything on that. I didn't do anything. I have plenty of friends who do that stuff, though. Okay, so this is a pretty nice little image here. We're going to do the A-bells, the Coma cluster next, the A-bell 1656, which is a large group of galaxies. But this is a pretty nice image. I love the colors in this. But we're going to do A-bell 1656 next. Be interesting to see how many galaxies we can identify in this. Be interesting to see how many we can see. Alright, first sub-exposure coming in. We definitely got a few there. Definitely got a few galaxies in there. Let's put those on where they're supposed to be. And you can see there's a number of them in there. Some NGCs, a lot of more subtle ones. What you think is a star is actually a galaxy, and a lot of these are also galaxies, but my catalog only goes down to Mag 18, so a lot of them are just smaller and fainter, and so don't show up as well. And we got photobombed, yay, by a satellite. So these are all a lot of galaxies in here. We'll let it get a couple of more subs, and you see a lot of these are fuzzy. Galaxy. These are all galaxies here, not stars. Galaxy. Those are definitely galaxies. Galaxy. That's kind of an interesting one. These fuzzy things, galaxy. Lots and lots of them. Galaxy, galaxy, galaxy. Lots and lots of them. Guess I should probably tell you what Arrow wrote here. The Coma cluster, the Coma galaxy cluster in Coma Berenices is visible in the east after dark. It contains over 1,000 galaxies covering over 2 degrees of the sky at a distance of over 300 million light years, and is one of the most prominent galaxy clusters. Most of the cluster members are ellipticals, including the 2 huge 13th magnitude galaxies, 2874 and 4889, at the center of the cluster. Both are visible, surrounded by a swarm of smaller galaxies at the center of this 6-minute capture. Yeah. And those two, obviously, are these 2 ellipticals there. But there's just galaxies everywhere in here. There, obviously. 4839 up there. That's a pretty bright one. The more you zoom in, the more galaxies there are. Keep zooming in, and there are more. Like I said, my catalog only goes down to Mag 18, so there's a lot more here, but I'm just not. I don't have the catalogs to indicate them. So you see a lot of these other smaller ones are going to be like this one here definitely is a galaxy, but it's fainter than Mag 18, so it's not showing out. It's not being indicated by my annotation. So Cool. Well, that's a heck of a field of galaxies, no matter where I zoom in, how much I zoom in. Pull up the annotation, there's another screen full of galaxies. Just a ton of them. That's pretty cool. Okay, well now for something completely different. The Owl Nebula. So a planetary nebula we're going to do next. In fact, this is going to be a twofer, because I have the field of view that allows me to get more than just that. And let's just go, because we're going to get also M108 here too. Why doesn't it show up? M97. It's right there. For some reason it doesn't show up. We gotta zoom way in. Anyway, we will center our view on that star, and then we'll get them both in one shot. Okay, let's play solve on that. That should have both objects in our view. Although I'm not seeing either one, well, we'll take our first sub. Worst case, if we're not there, then alright, while that's loading, I want to look at, I think 83 is one of these guys. No, it's not. Yeah, there it is. Southern pinwheel. That's what we're going to do next. M83, which is in the list as this is a deep southern object. 5128 and 29. No, 5128. Oh, 5128 is a special deal. That is Centaurus A. That's this one, I believe. Yeah, 5128. Yeah, that actually needed to be done a little earlier. That's going to be a little too low to my southwest now. I don't think I can give it a shot. Yeah, I actually got that a few weeks ago when it was on this side, and it was pretty nice. Anyway, here is M97 in the lower right and M108. So the Owl Nebula and the Surfboard Galaxy, which is M108. Both of them are in the view here. Actually, you know what? Change of plans. These will be in a good position here for quite a while. I'm going to come back and do these, because if I'm going to do 5128, I should do it now, because it's getting lower and lower by the minute. Hopefully it's not already too low, but we'll see. So you can see it's this is the green line is my horizon line, so this is very low. Wow, yeah, and in fact I'm going to have to go get my light shield. So I'm going to be right back. This galaxy is so low that the scope is like pointing almost right at me. So in fact, I need to shut my light off. This is very low on my horizon. What is this indicating? This is indicating 9 degrees above absolute horizon. My horizon is probably a couple degrees higher than that, so it may only be 6 or 7 degrees off my horizon, so we'll see what we can get with this. It's a tough one. I should have done this earlier. I didn't realize this was one of the targets. I did not realize this was one of the targets. Yeah, in fact, my guider's having a little bit of trouble down there as well. So it will intermittently complain. I don't know how clean an image I'll get of it. I should hopefully get something. But it's may not be the greatest image. Yeah, there it is. Okay, let's clean up the colors, clean up the stretch. And there's Centaurus A. And stars are a little bit oblong-y, so I may just end up killing that first sub and starting over. It looks like the mount wasn't quite settled. Then again, when objects are this low to the horizon, guiding is usually quite a bit of a challenge anyway. So, but I'm going to delete this first sub, and hopefully the second sub will. This sub will have rounder stars. Yeah, those are a lot better. Those are a lot better, which means the detail will be going to be a lot better in the galaxy as well. But this is a pretty cool galaxy. And you have to be pretty far south to be able to see it. Let's see. So, we'll come back to the Owl Galaxy. The Owl Nebula later. 5128. Centaurus A. This fascinating radio galaxy located far south at about 12 million light years away in Centaurus barely culminates at a little over 13 degrees at my location in early May, a bit after midnight. I'm about half that right now. So for many northern observers, this target may not be accessible. However, for anyone that can see it, Centaurus A is the 5th brightest galaxy in the sky, with a distinctive twisted dust lane bisecting the galaxy. A supermassive black hole lies at its center, powering 2 relativistic jets that are the source of both radio and X-ray emissions. Although the jets are beyond the reach of EAA, some amateurs doing AP have captured parts of them. As an EAA challenge for this target, try and see how much of the central dust lane you can make out. Well, we're not going to do too bad with it, it looks like. A little noisy at the moment, but as time goes on here, we will go back off on the saturation a tad. Hi Marco, what kind of scope am I using? Well, let me show you. That's my scope, 6-inch imaging newt, f4 native. I'm running it at f3 with a Stellarium nexus, Coma corrector reducer, and ASI 183 camera in the focuser. Running on the ZWO AM5 strain wave mount, all mounted on top of my spare no expense cinder block pier. So just simple imaging Newtonian. Simple, cheap, and very effective. What else has he got? Oh, M83, yeah. Well, M83 is up much higher than this. Where's 2997? No, not that. This. 83 is up higher. 2997, where the heck is? Oh, wow. Okay, well, obviously we're not doing that one. That one's set a long time ago. In fact, I don't think I can get that one anyway. Okay, well, we can do M83. And then we'll work our way back up. Marco says, wow, that's great. Did you have to do anything special to the tube to reach focus? For example, I can't reach focus with the reducer on mine. I would have to bring the mirror closer to the objective. Well, actually, I'm not sure what kind of newt you have, but on mine, you can see from this picture how far out the focuser is, because these particular newts were designed with DSLRs in mind, where the sensor is deep inside the body of the camera. So the focal point is actually fairly far out here. So with a DSLR, the focuser could be in quite a ways, and you hit the focal plane on the sensor at the back of the DSLR. Well, when you're using a dedicated astro camera with the sensor on the front, that means the focuser has to stick way out. So I actually had a custom mirror cell made that actually, as I've got the mirror back about 30 millimeters back behind its normal position, so that with an astro camera, the focuser is now much closer in. And so, for me, I'm able to achieve focus that way. The Stellarium nexus, I think it was 8 millimeters. Was it further in or further out? Anyways, 8 millimeters difference. So it's still quite a long ways further in from here. But on my imaging Newtonian, at least, I was able to achieve focus with both the Skywatcher Coma corrector at native focal length and the Nexus at 0.75 reduction. So I am able to achieve focus on both, and I can adjust the mirror with this new cell. I can adjust the mirror forward or back as I need to make sure that they fit. So it seems to me when I put the Nexus in, the focuser was so close in that I believe the draw tube stuck into the optical path, stuck into the light path. So I had to move the mirror forward a little bit from where I had moved it back toward, just so that I could have the focuser out just far enough so that the draw tube was not in the optical path anymore. So so I have a mirror cell for the primary mirror that allows me to move the mirror backwards or forwards from the stock position to accommodate these kind of things. So but even if I didn't have that cell, it would still have worked for both of them. It's just that the focuser, like you see here, the focuser is just sticking way out, and which can make for some sag in the focuser. Now I only have a camera stuck in there with a coma corrector. I don't have filter wheels, and I don't have EAFs and all that sort of stuff. I don't have any bunch of that stuff hanging off the focuser, so I didn't really got much focus sag, but still it's better to keep it closer in as you can, because it just keeps sag from happening. So, but and if you have a non-imaging Newtonian, you may run into the opposite problem, where you don't have enough back focus, especially with a reduction. A reducer like the Nexus, you may not have enough back focus. So, well, what time is it? See, it's 11:23. So, unfortunately, here, pretty shortly, I'm going to start running into moonrise. I think the moonrise is in about 40 minutes, which means in about 10 minutes, the sky is going to start to get lighter and lighter. And so I'm not going to be, when that starts happening, I'm basically done. But I think we got a decent image here of the, I want to give it a full 15 minutes though. Centaurus A does deserve a little extra time to clean it up. It's a beautiful galaxy, very peculiar looking, with that dust lane, that oddly shaped, odd-looking dust lane. Well, if you're going to stay in if you want that range, which you may, I don't know if you've seen some of the more recent quiz videos on YouTube, but the Carbon Star 150 is, a lot of people are really liking it. It's basically a carbon fiber version of my scope, with much better hardware, much better secondary and primary and adjustability and collimation ability. Carbon fiber tube, optimized for smaller sensors, 1 inch and smaller sensors, so 533, 183 and smaller, but getting some rave reviews. So you may want to just look up on YouTube for Carbon Star 150, or on your favorite astronomy forum. There have been 2 or 3 threads about it on Cloudy Nights, I know. But yes, if you're looking for a 5 to 6 inch scope, the Carbon Star 150 is something worth looking at. I considered it, but I've got so much blood, sweat, and tears into into my existing 6 inch. This is actually an old picture with the stock mirror cell. I had to have the custom cell on it now, but I've spent so much time tweaking and tuning this thing and have it in a place that's that I'm really happy with, so it's not worth me making a side grade into a better 6 inch. So I'm not going to be doing it, but it's worth considering if you're wanting to get a new scope. Alright, there's 15 minutes on Centaurus A, a very cool looking galaxy. Let's go to M83 next. M83. M83, go. Not a lot higher, but some. Bring that baby right down there. Okay, you. M83, or the Southern Pinwheel Galaxy. The Northern Pinwheel is M101, which is up underneath the Big Dipper. But this is the Southern Pinwheel Galaxy. Also a pretty galaxy. Smaller, but still pretty spectacular looking. We'll see it here in a few seconds. There we are. Southern Pinwheel. And this is obviously way too blue, so we need to get some colors fixed. And the stretch fixed. And that's a good start. And like I said, we'll have to start watching as the subs come into the sky get lighter or darker. As the subs come in, the second one's about to hit. It should get darker. Boom, yep, see it got darker. That's a good sign. That's what you want to see. You want to see the background get darker with each sub. When the moon rise starts coming, it'll do just the opposite. The background will start getting brighter with each sub, and that means we're done for the night. Usually that starts happening around about half an hour before moonrise, and I think the moonrise is very shortly after midnight. So yeah, definitely look up the Carbon Star 150 if you're looking for something in the 6-inch-ish range for an imaging scope. It's looking like a great offering. Certainly better than the like the ones I have, the cheaper ones, the Skywatchers and the GSOs. The optics are great. The optics are always great on these things, but the hardware is really cheap. The spiders and this primary cell, they're just cheap and they're sloppy, so that makes them harder to collimate than needs be. And the Carbon Star is basically it's a significantly uprated GSO imaging Newtonian. Better cells, better holders, better collimation gear. The focuser, well, I found the focuser pretty good in this already, but it's a slightly better focuser. A smaller secondary than normally you find in an imaging Newtonian. With mine this imaging Newtonian, I believe the secondary is 72 millimeters, or is it 82 millimeters? And anyway, in the carbon star it's 62, so it's smaller, which is why they limit the sensor size to a 533 and smaller sensor. But it lets more light in, so they've really kind of optimized it for the 1-inch and smaller sensors. People have been using 2600s, the APS-C size sensors, but you get some vignetting, so you have to either take it out with calibration files or just crop it out. But no, if you're using smaller sensors like I do, my 183 here, it works pretty well. And people have been really liking it, so worth looking at if you're going to be doing imaging. Okay, get you dialed in a little bit tighter here. It is a beautiful little galaxy. For northern observers, this beautiful barred spiral anhydra is still low in the southeast early in the month, higher in the sky later in the evening, or for our southern hemisphere observers. M83 is a face-on barred spiral about 15 million light-years distant, and it exhibits a lot of detail, knotty regions of star formations in its spiral arms, as well as distinctive dust lanes in its disk. For a challenge, try to see the two tiny neighboring galaxies, BGC 48132 and BGC 724-525, a little due east left of the outer spiral arm. These are visible in 9-minute capture. Okay, let's see. His images. See, his images upside down, so it's going to be over. So they're going to be over here, I think. Over here or over there? No, they're over here. They're over here somewhere. 2-star, right there. Oh yeah, they're right in here. These fuzzies right in here, I believe is what he's talking about. Well, let's pull up the annotation and it'll show us. (48.132), yeah, right. And then the other one he says here, this is PGC 724-525. So these are the two galaxies he's talking about. Are the Uber Challenge. I think we can see them pretty well. Alright, let's watch this sub come in and see if our skies are continuing to well, didn't notice it getting any lighter, so still good. Yeah, modern sensors are amazing things. The ability to do long exposure just gets you so much deeper into the sky. It would take a pretty big scope to see this visually, that's for sure. Those two little guys. Is that what it was? Was it Mag 16? I didn't notice. Yeah, Mag 16. So this one's probably 16.5 or 17. Actually, I'm surprised. Let's see if I get... Let's see if it actually shows up if I zoom in. This doesn't look that much fainter. My catalog is supposed to go down to Mag 18. Yep, there we go. It showed up. Mag 17. So they're calling it Mag 17 for the other one. Now it looks terrible when it's zoomed in that far because it's too pixelated, but still. Yep, so this is Mag 16 and this one is Mag 17. And my catalog does show it, but you have to zoom in a long way to see it. Okay, there's a good 15 on the southern pinwheel and friends. So let's zip back up to the 2 targets we abandoned earlier. And those will be it for the night. Okay, it's going to be up here. And 108, let's get in there. Okay. And we'll take that star there. We'll head back up and get the last one. Those last 2. Okay, so the moon will start rising here pretty soon, but the scope's pointed in the opposite direction. We're in the northwest sky now, so it pointed away from where the moon's rising, so we should be able to get a few minutes on these 2 objects. Okay, let's get the colors fixed and the stretch fixed. Owl Nebula and the Surfboard Galaxy. This is an interesting image because these are two very different objects. Obviously, the surfboard galaxy in the upper left is an entire galaxy of hundreds of millions of stars, if not billions of stars. And a little blue planetary nebula down there is just a little nebula that's in our galaxy. Planetary nebulas have nothing to do with planets. They were a bit misnamed, but basically it's the death process of a star, much like our own sun, where it runs out of fuel and starts burning a different fuel and swells up a whole bunch as it's doing so. Turns into a red giant, which is what's going to happen to our sun in about 4.5 billion years. And when that happens, it starts expanding and expanding and blowing off layers of gas and material. And star doesn't go out. The core that's left still burns. It burns cooler and dimmer than it used to, but enough to illuminate all of the stellar matter that it's basically blown out away from itself. And that's what creates the planetary nebula itself, is the core star continuing to illuminate its outer material. So you can see, if we zoom in here, you can see the core of the star still there. These two stars are most probably foreground stars, or maybe even background stars in the Milky Way, but this is most probably the stellar core that's continuing to illuminate all of the gases that are being blown out away from it. And this dark patch here, which is dark eyes, which is why it's called the Owl Nebula, are just part of the magnetics of the stellar core that's left, blowing out all the material and illuminating it as it goes. So two just very different objects in the same view. It's pretty cool. Sort of looks like a lumpy, odd-shaped galaxy. But I think this is probably, I don't think that's the core of the galaxy. I think that's a star in the Milky Way. I think all three of these are, 1, 2, 3, are actually stars very much in the foreground in our own galaxy in the Milky Way. Just happen to be right in front of the galaxy itself that's in the background. Okay, we'll take this last sub, and I think I will be calling it a night. Thanks everyone for watching. I hope you learned something and got to see some of the beautiful things in our skies. And yeah, I will hopefully be on again soon, but you never know how the weather's going to go and schedules and all that sort of stuff. So, but hopefully I'll be on again before too long. In the meantime, everyone have a wonderful evening, and keep looking up at those stars.